We are going to look at video number 6 homework that is due on the 13th, which is today for me while I'm making this video. On this homework, we started section 3, chapter 3, and it starts with just determining whether or not something is a polynomial. Let's talk about what would make it not a polynomial. If there was a variable on the bottom of a fraction, or if there was a variable underneath a radical symbol. So in this case, this is a polynomial because I don't see any fractions that have anything other than a 1 on the bottom. And this is a polynomial also. I don't see much for fractions, and there's no variable under the radical symbol. This right here does have a variable under a radical symbol, so this is not a polynomial. So it's just two things you're looking for, and that's a variable on the bottom of a fraction and a variable radicand, because if you remember, this is a radical symbol, and whatever's here is called the radicand, and you can't have that be a variable. If we look at number 4, we're looking at a polynomial. If we wanted to get even more specific, we could call this a trinomial because it has 3 terms. I'm looking at each term individually to find the degree of the term, and the degree of the term is really dependent on whatever the exponent is in that term that's attached to a variable. So right here I have x squared, so the degree of this is 2. That 2 comes from right here. The degree is 1, and if I have a constant, the degree of that would be 0. So I'm going to say 1 and I'm going to say 0. And the degree of the polynomial is whatever one of these is the highest number. So in this case, this is the highest number, so the degree of the polynomial is going to be 2. We call this a second degree polynomial. If you recall or seen at any point, anything raised to the power of 0 is 1. So if I have this, then and I multiply it by 1, it doesn't lose its value. And if I have this multiplied by this, then it doesn't lose its value because this is equal to 1. And that was just me showing you how the degree of that term would be 0. Okay, let's look at number 5. We are adding 2 binomials. Because there's a plus sign in front of the set of parentheses, I could write this out in this way. I'm distributing a positive 1. This is 7x plus 12. 7x plus 12. For this one, you have to distribute that negative symbol. So I have 16x minus 14 minus 10x minus 8. 16 minus 10 is 6. Negative 14 combined with negative 8 is negative 22. You just have to remember that terms are only like terms if they have matching variables and exponents. So if I have another term here that has an x cubed z squared, I would highlight it. There's one that has an x cubed z squared. If I have another one that has an x squared z, then I'm going to highlight it. I don't, so that's the only one of that kind. I have 11z. It will only be able to be combined with other z terms. And then I have, lastly, an xz term, which doesn't have a companion. Remember that before I can do any like term combining, I have to distribute my negative 1 so that I can get rid of all of these parentheses. And so that would basically make this first term negative, the second one positive, and the third one negative. It just changes the symbol so that when I'm going ahead and I'm combining like terms, this is a 9 combined with a negative 6, which is 3. This is a negative x squared z, negative 6x squared z. It had nothing to combine with, so I'm just leaving it the way it is. So far I've taken care of this, this, and this. 11z combined with negative 2 is 9. And then I have what was left, which was the 5xz. Number 8, we are multiplying. Multiplying is different. My favorite method for multiplying is using the box method. You can also do double distributing. I am making a 2 by 3 box because I'm multiplying 2 terms, 5a plus 7, times 3 terms, 4a squared minus 5a plus 3. If I go ahead and I do the area formula, this first one is 20a cubed. The second one is negative 25a squared. 5a times 3 is 15a. 4a squared times 7 is 28a squared. 7 times negative 5a. And 7 times 3. I want you to notice also that we have on here, if you look at the diagonals, like terms happen to naturally fall on diagonals. And I can go ahead and combine them on the way down. So my first diagonal is 20a cubed. Then I can combine these two because they're like terms, and that would give me 3a squared. I can combine these two, and that gives me negative 20. And then I have 21 at the end here, and that is going to be my product for terms after combining like terms. Going down to the last page, is that really truly the last question? There was only 8 questions apparently, which is amazing. Okay. Don't forget that you have an exam due at midnight, exam number 2, that is based solely on the homework, or I'm sorry, it's posted and there's a Kahoot version of it. Make sure you do both, and I will see you on Tuesday. Have a good evening.